wanted to introduce the microscope to you guys. Dr. Jason Sylvan also uses a microscope, so he's going to talk a little bit about his microscope, and then I will show you the one that we use.
Okay, we're on. It's me, Jason Sylvan again, still at Texas A&M University if you're watching this video, probably right after the one you just saw. And we've moved from the kind of, the room that I was in before was where we run DNA gels to see if we're doing lab work correctly, basically. We moved from there into my microscope room. So this is my microscope, and behind me you see one of my favorite videos of a bunch of bacteria eating oil. So in that particular video, all the little blue dots are single bacteria cells, and the kind of these gold dots here are little droplets of oil. And so one of the things I study is how bacteria eat oil after oil spills, and kind of clean that up naturally.
So here is the microscope that we have at Memorial Junior High, and I'm going to run through the parts really quickly. So this is the eyepiece. So this is the part that you actually look through. The eyepiece itself has a 10 times magnification. And then we have the objective lenses. Our microscope has 3 objective lenses, and you can rotate the objective lenses to use the different sizes. You'll notice on the side of the objective lens, it has the magnification right there. And the way to find total magnification is to multiply the objective lens times the eyepiece. So whatever the objective lens says, in this case 40 times 10. Now, underneath that, you have the stage, and the way that I remember the name of the stage is I think that's where all the action happens, right? Kind of like when you watch a play, that's the stage right there. On the stage, you have stage clips. So the stage clips will move up and down and hold the slide in place. And you'll notice that I have a slide here right now. This one here is human blood. I also have some plant and bacteria cells on slides, and these are already prepared slides. You have the body of the microscope, which is attached to the base, and then you have the light, because this is a light microscope. It's an electric microscope, so you can turn it on with the switch. So that's basically how you're going to start out, right? You're going to turn on the microscope, and you want to be on the lowest power objective lens. Once you are on the lowest power, then you can go ahead and start to focus. The way that you focus is you use the coarse and the fine adjustment knobs. You always start with the coarse adjustment knob and then make any small changes with the fine adjustment knob. So in other words, get it as clear as you can with the coarse adjustment knob, and then perfect it with the fine adjustment knob. When you move the adjustment knobs, the focusing knobs, you'll notice that it moves the stage up and down. So you need to be careful to make sure that your stage does not crash into your objective lenses. You always start with the lowest power objective and then move up from there. So you always start with the lowest one, focus it there, then move to medium, focus it, and then move to large. I know that that sounds kind of frustrating because you want to hurry up and you want to get to the coolest image, but trust me, it's just going to frustrate you and give you a headache if you try to go to the largest power objective lens and then focus it. It's just more difficult. Now, notice how the largest power objective lens is very long. That's what I'm talking about. When you move the stage, make sure that you don't crash into the objective lens, because you can break the microscope slide, okay? There's frozen water molecules that have been found beneath the moon's surface. Do you think that microbes live there?
That's a really good question. It's really smart, and that falls into the part of my work that's called astrobiology. And the question is basically, if there's water there, might there be microbes? And in some ways, the answer is that there could be. Water is one of the minimal requirements for life somewhere, as we know it. It could be life that looks really different from what we know. But there's a lot of other things that an organism would need too, like probably an atmosphere and some other things. So on the moon, I would guess there probably hasn't been stuff that has been alive. Although places like Mars, which we think may have had an atmosphere, there's definitely water, and some of the other bodies in our solar system are of high interest for people trying to see if there are signs of life either in the past or current.
How did you feel when you found the new organism?
I was really excited. Yeah, I mean, I maybe you would think that would be the case, but it's really cool kind of finding something that nobody else has seen before, and then getting to, especially when you've found a microbe, right, or a new species that's actually alive and you can work with it and see how it lives. That's really fun because you don't know what you're going to find, and that's at its heart, that's what drives all scientists. Just you don't know what you're going to find and trying to understand how the world works.
So that is basically the microscope. It just goes to sleep. It's still recording. I hope. Yeah, it's still recording.